Yes.
Yeah.
All right. Who's Hussein Muhammad?
Mustafa.
Okay, let's take the attendance. Ali, Aisha, Farida,
Here.
Hannah.
I'm here.
Okay, dear.
Here.
Hala, Hala. Okay. Haya. Yeah, Hala, I know you're here. Haya,
Here.
Khulud,
Yes.
Limar,
Yes.
Malak,
Here.
Mariam. Mariam is still connecting. Hamad Ahmed is not here. Mustafa,
Yes.
Najat, Noor and Yasin Tamer, Ruqayya,
Here.
Yasin Abdul Hamid,
Here.
Yasin Muhammad Radwan.
Yes.
Okay. Noor and Yasin is coming in. Okay, guys, we are going to continue answering the worksheets. I was supposed to put a homework for you yesterday, but something went wrong with my laptop. I couldn't do it. I fixed it late. So it's okay. We're going to do it together. And if we didn't, I'm going to give you as a homework during the weekend. Yasin and Noor, did you join us? Yasin and Noor. You're here?
Yes, miss.
Okay.
Yeah.
Okay. So let's just start. We stopped yesterday where, at which page? We stopped at page 32, I guess. We were doing question number 7. And we said that in question 7, the answer will be, it is neutral. Okay. Now we are going to open page 33.
Miss, did you have homework yesterday?
I was just saying that, yes, you were supposed to have a homework yesterday, but I had a problem with my laptop and I fixed it late, so I couldn't upload the homework. So we're going to do it together. Okay?
Yeah, we're going
Page,
to do it together and we will have a homework today.
if we finished all the worksheets, you will not have a homework today.
Okay.
All right. Now open page 33. So Mariam is here. Ali, did you join us? Ali? All right. So yesterday we started with the question number 7 from page 32, and we said the question says Paul had 4 substances. This is the page previous to the page I'm opening right now. Okay. Paul had 4 substances: citric acid, copper sulfate, indigestion tablet, and sugar. He dissolved 1 gram of each substance in 20 cubic centimeter of distilled water. He used universal indicator to find the pH of each solution. The first one, sugar solution, does not change the color of green, universal indicator. So this means that the sugar solution is neutral. The next question is in page 33, this one. Suggest the pH of citric acid. Citric acid is a weak acid, guys. So what do you think the range of its pH? It could be between what and what? Yes, Hala.
3 to 6.
3 to 6, very good. So it's going to be between 3 to 6. Okay. Next, indigestion tablets neutralize acid in the stomach. What does this tell you about indigestion tablets? We want to know what's the nature of indigestion tablet. It's made of what? Which neutralizes the acid. What neutralizes the acid? This is the question. If you think it's a hard one, it's really easy. Yes, Limar.
The indigestion tablets have alkalis.
Yes, it's made of alkalis. It's made of an alkali. Thank you, Limar. So the answer for this question is just give me 1 second. It is made of an alkali. Okay. All right. The next question is an identification key. You will learn about the nature of each of the substances that Paul is using in his experiment, which are what? Citric acid, copper sulfate, indigestion tablet, and sugar. I will help you only with the first one. This will be your hint. Okay. The first one is, let's first read the whole identification key. Okay. So first, the first question says, does the substance dissolve in water to form a blue solution? If yes, then it's going to be one of those. If no, we're going to answer, we're going to ask a new question. Does it turn the universal indicator red? Okay, so you have to think about what turns the universal indicator red. What is the nature of the thing that turns the universal indicator red? Is it an acid or an alkali? If yes, you're going to write it right here. If no, does it turn the universal indicator blue? Again, you have to think about what turns the universal indicator blue. Is it an acid or an alkali? If yes, you're going to write it here. If no, you will write the remaining name that will remain from all of the names up here. So I'm going to give you a hint. The first hint I'm going to give you is the first one. Does the substance dissolve in water to form a blue solution? The only one from the only chemical from all of those chemicals that can turn the color of the water blue is copper sulfate. Okay, and I'm going to show you right now how can it do this, or how it looks like. Okay, so we're opening Google. Okay, Here you go. Can you see it? Huh? Do you see it?
Yes.
Okay.
Yeah.
So this is the color of the copper sulfate salt. The powder itself is like baby blue. And when you add it to water, it turns the color of the water into this color. Okay. So this will be your first answer. Here, you're going to write copper sulfate. Okay. This is going to be copper sulfate. Now I need you to think about the rest. Okay. So no, it doesn't turn the color of water into blue. The next question is, does it turn universal indicator red? What turns the universal indicator red, the acid or the alkali?
Can I say
Okay, Ruqayya.
acid?
Acid. So which one will turn the universal indicator red?
Citric acid.
Citric acid, exactly. So this is going to be the answer, citric acid. If it turns the universal indicator red, then it is citric acid. All right. Okay, it doesn't turn the universal indicator red. So I will ask a new question. Does it turn it blue? Huh?
Can I?
Who can answer this? Who said can I? Would you please raise your hand so I can see? Huh? Limar and Ruqayya, okay. Huh? Who else? This is an easy one. What turns the color of the universal indicator blue, guys? The acid or the alkalis? Huh? Limar. Yes, Limar.
If yes, it's the indigestion tablet. If no, it's
Yes,
sugar.
because okay. So yes, it's the indigestion tablet. This means what? That it what turns the color of the universal indicator blue?
Miss, can you hear me?
I can, dear, now. What turns
Okay.
the color of the universal indicator blue?
Color.
The acid or the alkali?
Alkalis.
Alkalis, exactly. So if yes, it's going to be the indigestion tablet because it is made of alkalis. And if no, it's going to be sugar. Because sugar, as we said before, is neutral. Okay. So we're done with page 33. Now I need you to open page 34 and I need you guys to pay attention because it's a little bit tricky. The questions in 34th and 35 is a little bit tricky. So I need you to pay attention and please wake up with me. Okay? This sleeping mode that you have since the checkpoint is really annoying me. Okay, I need you to wake up. The year did not end. It still has like 2 weeks. So please wake up. All right. In question number 8, you have the Arctic regions, where is the places that have a lot of ice in it. And the Arctic region specifically is the North Pole. Okay, so in the Arctic regions, snow lies on the ground all winter. We know this. Okay, so snow is what? It is solidified water or frozen water. As spring approaches and the air warms up, some of the water in the snow evaporates. Okay, some of the water in the snow evaporates. Later, all the snow melts. Okay, so again, what happens? Normally in the winter, the whole thing is frozen. Once the spring approaches or starts to come in, the water in the ice starts to evaporate. Some of the water in the ice starts to evaporate. until the spring starts to get in or kick in really strong. In this case, the snow will start to melt. Okay? How does the evaporation of the water in the snow affect the concentrations of acid in the snow? I want you to think about it. This is related to the part where we were talking about dilution. When I told you that the dilution does not affect the amount of the acid, it affects its concentration only. So in the snow and in the water and in the rivers and all of the water surfaces, it contains some acids in it naturally. It contains some acids in it naturally, which comes from natural processes. Okay, you don't have to know about it, but it contains a little bit of acid in it. Now, my question is, you have snow which contains acid. Some of the water in the snow evaporates. What will happen to the concentration of the acid in the snow when the water evaporates? Raise your hand if you got the idea. Limara and Ruqayya, do you know or did you forget to lower your hand?
I know.
Okay, what about the rest of you? Am I giving this lesson only to Limara and Ruqayya? I was just saying, please turn on your studying mode again and turn off the aeroplane mode because it's getting really on my nerves. Every time I enter a session with 6A, only 2 to 3 and 4 people contribute with me. The rest are totally asleep. Where are the rest of the class? If you don't want to attend the session, just go. But this way, every time, I feel like I'm totally ignored, like I'm doing a wasted effort. This is effort wasted. If you do not want to attend the science session, just go. I'm talking to myself. I swear to God, I am talking to myself. Where are the rest of the people? Are you there, guys? Are you even here with me?
Yes.
Yes.
Yes, yes.
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 Okay, so again,
Yes.
you have some acids. You have some acids that are dissolves in the snow. You have some acid dissolved in the snow of the Arctic region. All right, it's naturally occurring there. Now, after a while, when the spring starts to kick in, some of the snow will evaporate. What will happen to the concentration of the acid in the snow after some of the water evaporates? Yes, Limar.
The acid will be diluted.
So this
It will
means
be
that
concentrated.
so the concentration will increase, right?
Yes.
So this means my other question, because this is a little bit tricky, okay? So the concentration of the acid will increase. This means that the pH of the snow will increase or decrease. Think about the question really well. You said that the acid concentration will increase. This means that the pH will increase or decrease.
Increase.
Think about it, Limar. The acid concentration increases. You have more acid. So the snow pH will do what?
Decrease.
Decrease, because the pH, the low pH represents an acid, right? The low pH represents an acidic solution. This is why it is a little bit tricky, guys. Okay, so this is why I'm going to just explain it in a whiteboard so that everyone can understand. Okay, so when you have, when the concentration of an acid increases, acid concentration I would love if you wrote this. If you like to write it as a note next to the question, okay. If you have a specific copybook that you write in, that would be fine, okay? So I will increase the acid concentration. This means that the pH is decreasing.
Miss, beside question 8A.
Beside anything, you have a very large area under at the end of this page, you can write in it.
No, no, you missed. This is because
graph down.
graph down.
No,
so I will.
No, you will not plot the graph down. You will plot the graph in the graph paper in the next page. So this is an empty space you can write in it.
Okay.
Okay. So when the acid concentration increases, this means that the pH is decreasing. Why? Because low pH means acidic. Low pH means acidic. Okay? All right. What about if the acid concentration decreases? This means that the pH what? Increases, exactly. When the acid concentration decreases, this means that the solution or whatever is getting a little bit alkaline. This means that the solution is getting a little bit alkaline. So this means that the pH is increasing. Is it clear so far, guys? Do you understand?
Yes.
Okay.
Yes.
Very good. Now related to the question, the part related to the question, okay? You have acid plus water, okay? You have acid plus water. If the water evaporates, I will write it right here. Water evaporates. So this means what will happen to the acid concentration?
It will increase.
It will increase, exactly. So this means that the acid concentration will increase. Very good. So this means that what will happen to the pH?
It
will decrease. You have here what you need. You just have to look up there, Ruqay. Okay? I said that the acid concentration increases. This means that the pH will decrease. Okay? Ruqayya, did you get it?
Yes.
All right. The next part that I'm going to tell you about is if you have acid plus ice. if you have acid plus ice, and then ice melts. So this means what will happen to the water? Will it be more or less when the ice melts?
More.
So you have more water. This means that you have more water. What will happen to the acidic concentration?
It will decrease.
It will decrease. Exactly. Excellent, Ruqay. So this means that the acidic concentration will decrease because now you have more water after the ice has melted. So this means what will happen to the pH?
It will increase.
It will increase. Very good. Who doesn't understand? Huh?
I don't understand the last part.
The last part. Okay. All
The
right.
acid and the ice.
All right. Now you have acid. Acid in this question, I said that you have acid in the snow. And some of the water in the snow will start to evaporate. Will evaporate, not melt. It will evaporate. So this means that there is this part of the water just went away. You don't have it anymore combined with the acid. So you have less water mixed with the acid. What will happen to the acid concentration?
It will increase.
It will increase because the water evaporated. It's not there anymore. The water evaporated. It's not there. It's not mixed with the acid anymore. It left the acid and it evaporated in the air. So it leaves the acid by itself. This means that the acid concentration will increase and the pH will decrease because now it's more acidic. The snow is more acidic. Okay?
Okay.
Now, if you have the acid that is combined with the ice, all right? And the ice started to melt. The ice started to melt. Now you have more water mixed with the ice, with the acid, sorry. It was ice at the beginning, okay? It was ice at the beginning and the acid was concentrated in this ice. Now the ice melted and you have more water mixed with the acid. What will happen to the acid concentration?
It will decrease and the pH will increase.
Exactly, it will decrease. Now you have more water mixed with the acid, so the concentration of the acid will decrease. This means that it is less acidic. This means that is less acidic, so the pH will increase. Do you understand it now?
Yes, thank you.
You're welcome. Did you write everything?
Yes.
Okay, now we can answer the question. Okay, I want you this to be in front of you while we're answering those two pages, page 34 and 35. It will help you a lot. Okay?
Okay.
All right.
Okay.
Give me 1 second, guys. Okay, guys, so I'm going to get back to the page again. All right. So as Limar said, how does the evaporation of the water in the snow, and it's evaporated, it's not melting, it's evaporated. This means that the water just left the acid. Okay, it's not mixed with the acid anymore. How does the evaporation of the water in the snow affect the concentrations of acids in the snow? So as Limar said, the concentration of the acid will the acid concentration will do what?
will increase.
The acid concentration will increase. So what will happen to the pH, Ruqayya?
It will decrease.
It will decrease, exactly. And the pH of the snow will decrease. Is it clear for everyone? I think now that you have this map, this chart that I made you, you will find it easy.
Yes.
Okay, so the acid concentration will increase and the pH of the snow will decrease. Why? Because the water has evaporated. It left the acid and it went in the air. So this means that the acid now, the concentration of the acid is more. Does that mean that the amount of the acid changed? Did I add more acid?
No.
No, I did not add more acid. The amount of acid is the same that it was already in the snow. Only the concentration changed because what diluted it evaporated. The thing, which is the water, which diluted it, evaporated. So this is why we said that it's more concentrated now. Okay? All right. Now let's go to plotting the curve. You need to do a line graph using this table. Okay, so where should you do it? You're going to do it in the graph paper in page 35. First of all, we need to assign the x-axis and the y-axis. We need first to assign the x-axis and the y-axis. This is the y-axis and this is the x-axis. What should I put here and what should I put here? Whoever knows, raise your hand. You have this is the table is in page 34 and the graph is in page 35. Where were you, Najat, the whole session? Okay, so you have the table in page 34. In the table, we are comparing between the number of weeks and the pH of the ice. What does that mean? Let's open page 34 again. Open it with me, please.
What page?
Open page 34. Page 34.
Okay. I'm opening it.
Okay. In page 34, the table shows what happens to the pH of the snow during the weeks of the spring. Okay, so in the first week in the spring, when they measured the pH of the snow, they found that the the pH of the snow is 7.1. Okay, in the second week of the spring, they measured the pH and they found that it is 7, the pH of the snow. In the third week, the pH became 6.9. In the fourth week, the pH became 6.8. Notice that the pH is doing what? It's dropping, it's decreasing. Okay? All of this until week 7, it keeps dropping until week 7. In this whole period, the water is evaporating, not melting. The water from week 1 to week 7 is evaporating, not melting. So the water keeps leaving the acid and just go to the air. So this means that the acid concentration will do what? From week 1 to week 7, the acid concentration will? The water increasing, exactly. The water is evaporating, and this is why the acid concentration is increasing, and this is why the pH keeps decreasing, because the water or the snow keeps getting acidic and acidic and acidic and acidic. Okay? Is it clear?
Yes.
All right. Until week 8. What happens in week 8? What happened to the pH in week 8?
Increase.
It started to increase, exactly. So this means that
That
the
means
acidic,
that ice will.
yes, thank you so much, Hala. Very good, perfect. This means that starting week 8, the ice is melting. The ice is melting. So this means that the water is mixing even more with the acid, making the acid concentration less and the pH more. Do you get it, guys? Do you understand?
Yeah.
Yes.
Very good. Perfect. So from week 1 to 7, what is happening? The water is only evaporating, leaving the acid behind. So this means that the acidic concentration is increasing and the pH is decreasing. Until we reach week 8, what will happen? The pH will increase. The pH will increase. Why? Because now the water is melting and mixing more water with the acid. So the acid concentration is decreasing and the pH is increasing. Okay, now that we made that clear, we can plot the graph in page 35. Let's do it together. All right. So first, as I told you guys, we need to assign, I'm going to change the color. We need to assign the y-axis and the x-axis. What do you think should I put in the y-axis and what should I put in the x-axis? Should I put in the y-axis the weeks or the pH? And what about the x-axis?
Raise my hand.
Yeah, raise your hand. Who's yes, Najat.
I think we're going to the straight one. Is the the y-axis, right?
The one that looks up is the y-axis.
Yes.
Hmm.
Okay. So we're gonna put in the y-axis the pH scale.
Yes, the pH.
The weeks down.
And the weeks will be in the x-axis. Yes.
X-axis.
Yes. And the weeks will be in the x-axis. Okay. Now we're going to number them. We're going to number each one of those boxes. Okay. We need to number them. First, the weeks, it's very easy. You're just going to put it one by one, which means that you're going to start with 1, 2, 3. Each small box represents 1. 5.
Yes, there would be one left.
It's okay. We just need 10. 7, 8, 9, 10. Okay. What about the pH? Also, the pH, we are going to make it 1, 1 this way. We're going to make the scale 1. So each one of the small boxes will equal 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I think I'm going to end the session and start the new one. Okay, guys. I'll be seeing you in a while.
Okay.
More.